Hi everyone, and welcome to your lab number 3, body composition. Today we'll be covering a few different points to do with body composition and how that relates to health, wellness, and physical development through adolescence. As you can see here, we'll start off covering some of your activities that you do for this lab and giving some background information specifically on those. Such as the body mass index and hip to waist ratio. Then we'll give you a little bit of background as far as body fat and measuring that, what it means, and essentially what that'll look like once you do the activity with the skin fold calipers. There will be a separate tutorial and tutorials, so supporting information and YouTube videos on how to do that. And then last but not least, growth and development. And if you're planning on teaching physical education in late elementary or middle school or even high school, this will be particularly of interest to you. Or if you just plan on working with adolescents, children and teens in any capacity, especially to do with health, this will be an interesting component of that for you. So just a general overview, KINANTHROPOMORPHY. That's a long word. It comes up in your manual a few times. What does it mean? Really, it's just the measurement of our bodies and trying to relate that to any number of different facets to do with our health, sport performance, or growth and development, ultimately. So we see here, one of the points, it can be a health indicator. And there's a question in your lab that asks you this as far as what a possible indicator of a certain measure. I don't want to give it away. I'm trying to foreshadow it for you without giving you the answer. What is a certain measure helpful for aside from just aesthetics? So aside from just the look and appearance of, say, body fat, what do some of these measures do? And in particular, they can predict health. So there's been decades now worth of research that look at what being overweight and obese can do as far as predicting with health risk factors. Two things, one called morbidity and another term called mortality. Now, mortality's probably a little more familiar for most. It's essentially death. So how well can a certain health factor predict death? Well, in this case, being obese or overweight, based off of some of these metrics that you'll be doing in your lab today, are pretty good indicators and predictors of early death or earlier death. So not living to a full predicted lifespan. Morbidity is a little different. So morbidity is living with a chronic condition that is detrimental to your health. So morbidity might be something like cardiovascular disease or diabetes of some sort. Naturally, as some of you probably can imagine, the way our bodies are shaped or our composition that we hold can weigh heavily on sports performance and performance in physical activity. And we'll take a little look at a brief look at how that might be. Lastly, growth and development. As I mentioned, there's some pretty cool measurements that we can take for growing adolescents, I guess. I was going to say kids, but growing adolescents that help us predict fairly accurately when and how growth spurts happen. And what I want all of you to do, and it's important for your lab and quiz later on, is I want you to take a little bit of a perspective of if you're a coach or a coach of like a high school team or a middle school team. How would you approach training your athletes given this knowledge that we're going to cover in your lab? So first up is body mass index, and we're going to take a look at how this influences health or how to go about the measures and its pros and cons. no system or predictive model, as you found out when we did our screening process, is perfect. And if you really think back to the first lab that we did as far as looking at statistics and how that plays into developing these models, screens, and indexes, it really is meant to be models that are as predictive as possible, but clearly not perfect. And the more and more research that we find behind each of these tends to sway support or lessen its support for its use for various populations. So with that said, let's dive into this. So to get your BMI, you take your height and your mass. And if you look at the calculation there, you can see that it's your mass in kilograms multiplied by the square of your height. So whatever your height is, you square it and then multiply your body weight. That's your BMI index. Now, as far as health indices, so what do I mean by that? Health indices are predictors of those two terms I said before: morbidity, mortality, and other health factors. So how useful is this? Well, it's not really clear. The body mass index used to be very, and still is, widely used as an indicator of health risks and stratifications, but it's really not as clear as we thought. There was some thought that maybe having an inverted U, so if you're, let's say, in the middle as far as being slightly overweight, like low overweight, in that category is the healthiest versus not. So what do I mean by inverted U? Let's see if I can pull something up here. So an inverted U, you have this graph. Yeah. So X. So we can just say something like up here is good health of some sort, high health, this is low health, and then here's all our people or their BMI scores, okay? So BMI score. So an inverted U is an upside down U, and the idea is that those down here with their BMI being low or higher, relatively speaking, would have the poorest health outcomes. So, we have some sort of low score, low health. But as you get towards the middle, in particular an overweight category, in the low end, they're saying that you have high health outcomes. And then as you get heavier and heavier, you got low again. So there's the middle ground somewhere in here where you're supposed to have optimum health. The highest amount of health was supposed to coincide with a zone that was actually on the high end of overweight. I'm just going to go OV for overweight. Let's throw a W in there just in case. Oh, that looks like a huge squiggle now. These online whiteboards, not as good as the classics, but hopefully you get the idea here. So I'm gonna go back again and just kind of say that slightly different, just for clarity's sake. So on this end, with the low BMIs, these people would typically be underweight. So weighing a level that has poor health outcomes. For example, poor bone density, poor hormonal or reproductive health, usually consequences of low body weight. Over here with high, these people also have poor or low health outcomes. Remember, this is health over here. Healthiness. I know it's a very general term, but health outcomes. Okay. Oh yeah. Heal apparently is the word for health. So again, here these folks down here are not doing so good. These folks up here, the obese and morbidly obese, not doing so well either. They kind of hit this threshold of poor health down below. But if you are in the general overweight, so again, that's low over here. This is high. Let's say highly overweight and obese. There's this little bit of a sweet spot for a long time, for about a decade or so. Research was saying this is okay. You don't want to even be in the healthy range, which is somewhere over in this little fringe between these categories here. So even being in our category of BMI of normal healthy weight isn't even as good as being slightly overweight. And that was a thought for quite a while with your BMI. However, again, getting back to this slide, they're finding that's not the case. So BMI is, again, being less of a helpful predictor in figuring out these health indices. It's a place to start. But why do we use it then? That's a good question to ask yourselves, and ask as far as why people are still using the BMI. Clearly, the health outcomes that it's supposed to help predict is not as good as far as its criteria. So again, the studies are showing, they thought, okay, for someone who's, let's say, 5'10", and 200 pounds, 5'10", 200 pounds, it's right here in the overweight. People are like saying, oh, that's probably the healthiest, somewhere in here. I mean, more healthy would probably be right at that junction there. So if someone who is 5'10" was 173 pounds, that's perfect. That's great. That has the best health outcomes we're finding. So not even here in the normal range. But why is not even normal relating to good health outcomes? Like, why do we use this then if there's less support? Well, like a lot of things, so far it's quite widely used and implemented, and so that has a lot of sway in what's continued to be used. But again, critically, if you are going to implement this, it's great because it's quick, it's simple, and it's cheap. You need a tape measure and a scale, which, again, if you are working for the WHO, the World Health Organization, and you're going to these rural villages, like when I did a trip to India with a primary healthcare team, and you can go to these very rural villages and get a lot of good health information purely from weighing people and measuring their heights. It gives you a pretty quick idea as far as where they land on this chart, and then therefore a general idea of how healthy or unhealthy they might be. The disadvantages, as a lot of authors have come to find in the research, is it doesn't consider body fat. So a lot of you have come across the notion in just public mainstream media and like common thought is muscle is more dense than body fat. Now you're talking about slightly 0.03 grams heavier or lighter than a kilogram difference between muscle and fat, fat being slightly heavier, denser, and fat being less so. But the real health concern when you're talking about people being obese and overweight typically has to do with the body fat and the influences that plays on our hormonal systems and the rest of our bodies, our hearts, our cardiovascular system. So again, just a quick peek back at this chart, you can imagine in that scenario that if someone is in the normal category, or someone's in, say, the overweight category, and they're really, really lean, but they have a super athletic build, like really, really muscular, that's going to put their weight slightly higher for their given height. But that being said, is having more muscle unhealthy? No, that's probably why most research is skewing towards overweight, depending on the populations they're surveying. So it infers through someone's weight how much body fat or adipose tissue they have. That's the same word. So what you'll be doing in your lab, one of the steps is to have purely a waist to hip ratio measurement. How do you do that? Well, you take a tape measure, and again, there's a tutorial on this. You measure around your waist, so higher up on your abdomen, and then your hips, so lower down, and you make a ratio out of the two, quite simply with the waist over the height, and you get a number. So how good is this at predicting health outcomes? Well, we've come to find that it's actually better than BMI. So it more readily predicts people's health as far as a health outcome for their body mass relative to the body mass index. Okay, and so if you add waist to height to the BMI, as I was saying, it becomes even a better predictor. And this is sure enough this is what a lot of health and sport certification bodies now suggest that people do. It's part of their standards. And again, the more information you combine, the better it is. So if you start looking at height and waist to hip ratio, if you start looking at BMI and waist circumference, all of these just add slightly better and different clues and data into making a better picture and a better predictor of future health outcomes. So let's take a second to digest that. I was kind of rambling away there at you, getting you lots of information. So one of the issues with the BMI, right, was that it didn't use body fat percentage. So now if you think about that, and in particular abdominal fat. So abdominal fat in particular is a huge indicator, both whether it's on the surface by your skin or surrounding your organs, is a really, really clear indicator as far as health outcomes and mortality and morbidity. So once we start measuring, just purely measuring around your abdomen, waist circumference measure, how round are you? It's a really good indication of what additional body fat you have on yourself. So this is both for men and women. The hormones typically and genetics typically lead to where and how you store your body fat on your body. That'll dictate that a bit. But this measures kind of helps account for that, especially the waist to hip. So the advantages, just like the BMI, is quick and easy, simple, cheap. You don't need big machines or expensive lab equipment. Again, you just need measuring tape. Fairly attainable for most people in the world, regardless of poverty levels or not. And a good indicator of health, particularly when combined with other measures. Great. The disadvantage is, again, it infers rather than directly measuring body fat. So typically whenever we want to directly measure whatever it is we're trying to obtain. So in this case, we can do that. And so let's take a look at that now. So body fat, how do we measure it? How do we get a percentage? Well, one of the easiest ways, the most accurate way, so the gold standard, the one way that every other way is compared to, is called a hydrostatic dunk tank or tank. So you take yourself, or whoever you're measuring, and you essentially submerge yourself underwater. And the amount that displaces indicates your density. And from that, you can you get a very, very accurate measure as far as your body fat percentage. Now, another way you can do that is through something called a DEXA machine. And a DEXA machine, this is also very, very accurate, is essentially an X-ray machine that takes an X-ray of your body, and through the different densities that different tissues have in your body, it equates that to a certain amount of volume, and it can, from that, figure out how much of your body is body fat or adipose tissue relative to other kinds. And the great thing about that is it can actually get a good indication of what body fat might be around your organs as well, rather than just the surface tissues underneath your skin. The other ways that are a bit more common and a bit cheaper to do, one is bioimpedance. So if you have a scale at home that measures body fat, or typically a lot of gyms will have them, essentially that runs an electrical current through you, and then based off of muscle and fat conductivity, it infers how much of your body is fat versus muscle and bone, etc. So The issue with that is your hydration level. So the more hydrated you are, or the less hydrated you are, is going to change the conductivity of certain tissues, in particular your muscle. So you can really get skewed results from bioimpedance. And then last but not least is skin fold calipers. So this is what you get to do. This is typically what most people will do if you go see a personal trainer or a kinesiologist. They'll use the skin fold calipers because it's a great way to directly measure the body fat mechanically that you have in certain sites. And you'll come to find, because you'll be doing this yourself, that there's a few equations that you can use that. It's great to do things this way because you get a really good indicator of a direct measure of a health index, body fat, right? What else is great about your calipers? Are typically fairly cheap to get. There's some pretty swanky, expensive ones out there, but most of the time you can get a very accurate read with the cheaper calipers. It's just a matter of practicing. So ultimately, caliper measurements, it comes down to the level of experience that the person taking the skin fold measures has. I'll explain a bit more in the tutorial around this, but ultimately, when you're taking the skin fold measures, if the caliper doesn't have its own spring, so its own means of applying pressure, it's up to you to apply that pressure. And there's little gauges and a little click-in sort of part of most calipers that help you figure out what sort of pressure to put on the fat. But you really need to be careful as far as your technical, tactile skills to not overpinch, not underpinch, because you can think, and you'll find out if you just even take some body fat, or it feels almost like you're just pulling out your skin, and you squish that just with your hands, you can feel it kind of compresses. So again, if you're trying to get an accurate measure and you're over pinching with the calipers, you can actually under predict how much body fat you have, because you'll actually squish down and get a smaller reading. So just something to be aware of. So we've now, thinking back a bit before we get onto here, we've had a few different means. I'm even gonna scroll back. So we have the body mass index, 3 ways that we've covered here, and you'll add on a couple more through your lab manual as far as activities and measures. 3 different aspects of how to look at different predictors of health. Okay, again, we're still along that same mindset as last lab as far as trying to screen and look at an indicator or a measure that we can take that helps predict someone's health and outcomes, or health outcomes, sorry. But let's take a little bit of a switch of gears, and we're going to look more at sports performance, okay? Before we take a look at this chart as far as body fat percentage performance, let's go back and just take a peek at what a healthy body fat range for men and women will be. So notice here, generally speaking, being under fat happens a lot sooner. So you're looking at, depending on age, but we'll just generally look across all age cohorts here for men. You'll see let's say about 8 to 12%. That's the border between under fat and healthy. Now women, again, across all, you're still looking at like 22 to 25% is that same border, okay? So why is that? Why, you're probably asking yourselves, that seems a little odd. Ultimately, it's for reproductive means. So based off of female sex hormones and biology, their bodies are set up to store more fat in order to be prepared for life-giving and having childbirth, child rearing, all of that. And so estrogen, again, in particular, is a hormone that increases body fat percentage. Whereas men, again, we'll just look at the next stratification, is kind of 20 to 25. So for women, it's higher up to 35% across all age groups, again, generally speaking. And then again, as you get into obese for men, quite early at about 25%, which is very normal. It's a healthy range for women. You start getting into obesity depending on your age range. And again, testosterone has an influence in this for men in the sense that you'll tend to have more muscle mass on individuals with higher testosterone levels. Okay, so we won't look too much at the difference within each sport between men and women. But our first comparison I just wanted to point out would be between aerobic and anaerobic. So taking a look at, say, a sport like shot put relative to marathon running. Again, shot put is a throwing sport. You don't need to carry your body weight anywhere. In fact, the more body weight you have, the more momentum you can put or throw behind a shot put. In comparison, marathon running, you have your own body weight that you have to carry with you for 42.2 kilometers. Again, the less weight you have to carry, the better. So for men, again, you got a range about 5 to 11. Men in shot put, 16 to 20%. Okay, so quite a big difference between those two sports. And again, looking at elites, shot putters for women, 20 to 28. Marathon for women, 10 to 15. Okay. And again, that trended with aesthetic and non-supported aerobic-based sports. The higher the performance or performers of these, the better. Now, just to illustrate a fact of how that's actually not always true, we'll take a little peek at one study that looked at triathlons. So in triathlon, you swim, you bike, and you run. So you have two sports that are kind of not necessarily supporting your body weight, in particular swimming. Cycling, you still carry your body weight with you, so you'll notice the body fat percentages for cycling here are quite low as well, relatively speaking. But when you compare it across groups and based off of performance within certain races and distances, you find that with males, the lower the body fat percentage the individual had, the better they performed. Okay, and that kind of makes sense. The less weight you have to carry with you, the quicker you go. On the other hand, if you looked at females, it was actually based off of their training time. So the better trained female athlete was, that indicated her performance better, which I find really interesting to me as a coach, because that means focusing on a strong swim for women might be a better place to focus some training, because that's where typically body fat has a big influence, and also increasing training time for women. So when you look at that, it doesn't necessarily support that body composition dictates performance, and certainly that's the case. It can, like a lot of health screens and health indices, can help indicate and predict relatively well, depending on the sport, what performance outcome would be. But you can even take a completely different sport like sumo. That sport specifically, sumo wrestling, you need to have a large mass to help add momentum into moving your opponent around and being able to stay where you are. So again, it really varies depending on the situation as far as body composition and what it indicates as far as predictions. Shifting gears into growth and development. Now, again, taking an approach of a middle school coach for physical education or athletes, adolescent athletes, is really going to help out here. Maybe even just being generally interested in how kids or adolescents grow, and how you've grown and developed is going to be helpful. So we've all gone through, if you've finished your adolescence growth spurts, something called peak height velocity, which is essentially saying it is the maximum amount of height vertical growth that you're gonna experience. And that happens in a very specific order. Okay, so without reading this quote, although it explains it very, very well, you can look at it on your own. Typically, the order of which things grow are your feet and hands, then your limbs, and then your trunk or your body or your torso. And you can think of this too if you've ever come across when you see puppies, right, or very young puppies of large breeds of dogs. So you can look at their paws, and they just have these massive paws, and their limbs and their legs are super, super long, and they're all gangly and flop around and stuff. And essentially what that is indicating that their torso and their bodies are gonna catch up. So next time, I don't know, you're at the dog park or something like that, and someone makes a comment about a puppy being like, whoa, they're gonna be a big dog. You know, it's not even specifically based off the breed. You can just look at the size of the paws and legs relative to their body. Same thing with people, okay? And I kind of doodled in green arrows around our soccer players here to help illustrate that exact trend, okay? So hands and feet, arms and legs, then the torso. And knowing this allows all of us to do something really cool, especially when it comes to figuring out how to coach athletes. You know, for example, if you have an athlete who proportionately, and if you take these measures and you do this in your lab, you know, if you measure an athlete's feet relative to their legs and their torso, and they happen to be quite a bit proportionately larger, you know that a growth spurt is going to be coming. When you do their seated leg length height relative to their torso, you know if their legs are significantly longer proportionately to their trunk, or their arm span relative to their trunk or their body height, you know a growth spurt is going to be coming. So they're going to be hitting their peak height velocity, okay? And if we look at that graphed out, we get something like this. So ignoring all the little boxes for a second, you know, if we look at females, this is their age chronologically. Remember, developmentally is going to be different than their chronological age. So where each individual, where we've all hit our peak height velocity is different chronologically versus the development age, which is physically where we're at. Maybe you can think back to your own experiences on this just to help clarify that point. You know, if you're in grade 7, let's say, and you know, as you notice some of your classmates were quite tall at that point in time relative to everyone else. They're just going through their peak height velocity before others, right? So, yeah, getting back to this, again, that's what this is. So the height, you're growing, you actually slow in your growth for a bit, and then all of a sudden you accelerate up, and that's called a growth spurt, okay? And then you hit your peak height velocity through this period. So for women on average, it's just around 11-ish to about 12 and a half. For men, it's about 13-ish to about 14 and a half, 15 on average. And again, we can all think of maybe friends or peers that demonstrated just how different of ages people can go through this at. Now taking the perspective of a coach. So there's 5 different skills that you want to develop in all athletes. And depending on the sport, different skills are going to be more important. However, when you're talking about adolescence, and in particular just with physical education, generally speaking, there's there's 5 main skills that you want to focus on at different points in time. So they're the 5 S's. So you have suppleness, speed, skill, stamina, and strength. Okay? And suppleness is just flexibility. Stamina is like cardiovascular endurance. And I think the others are pretty straightforward. So depending on where people are on the development of their growth spurts and adolescence, that means you want to have different points of focus. So let's take a look here, and I'll just kind of explain a little bit how the graph works. Let's look at women, and the men will be pretty self-explanatory from there. So as you're coming along in chronological age, we can look at as this peak height velocity is slowing down. So chances are feet and hands start growing quite a bit here before their vertical height changes. So, you have your speed and suppleness. So the first time you can work on speed and flexibility is right in this range, right? You get some overlap with skills, so that's sport-specific skills. Depending on what sport it is, this will change. But it's usually a little bit more fine or gross motor, again, specific to the sport. So you get this window where you can really focus on that as their height kind of slows down. All of a sudden you hit your growth spurt, which is indicated by the green star and yellow arrow as that's happening. While that's going on, again, with women, you can focus a little bit on speed, but stamina is really important to focus on more so just kind of during after peak height velocity. And again, strength is something in particular you want to think about after peak height velocity. Okay, those two are important to consider. Okay. So again, following the blocks along the timeline, men, a little bit different, not really. Suppleness is important to work on early on, or a skill you can focus on. You get into the skills of the sport again before the growth spurt happens. You can work on some speed. But as peak height velocity is going on, again, stamina is something that you can focus on quite a bit. Speed is something you can work on. And again, once peak height velocity is completed, that's when you can work on strength, okay? And again, the reason for that is just based off of the changes that can happen by bearing external resistance and weight. So as we've come to find, body composition measures are really, really helpful and really important metrics that we can use and gain as health practitioners. So whether that's body fat composition, BMI with waist circumference or height, they all allow us as again, health practitioners, whether it's a kinesiologist, physician, or coach, to come up with efficient, smart, safe, and effective programs for our clients. So I hope you enjoyed this lab. It's a fun one, getting to learn how to use the calipers, and pretty interesting as far as going through the measurements of all the different body composition measures and figuring out how to do them and what they mean. So have fun with it.